Welcome learners, today we are going to learn about recursion. Recursion is a powerful technique that allows functions to call itself, opening doors to elegant and efficient solutions. Let's start with recursion. Recursion is a programming concept where a function calls itself during its execution. It's like a puzzle solving approach, breaking down complex problems into smaller, more manageable pieces. Let us see the basic structure of the recursion. Okay, this is the basic structure of a recursion where there is a base case and the recursive case. What is the base case means the function ends with its calls in this cases. Recursive means in this part where the recursion function call itself. In base cases, the function stop calling itself, and in recursive cases, the function call itself to perform some operations. This is the main parts of the recursion function. Let us see an example. This is a simple example for a recursive function. First, we give a Fibonacci as a function name, and we pass a parameter, and we provide a condition to check if n smaller than or equal to 1. If the n is smaller than or equal to 1, is just return the value of n. This is the base cases. Here the function stop calling itself when the condition is met. So we say this is a base cases. When the function call itself again, then we call this as an recursive case. Here see the else part. Here return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Here the function called itself in the else part. So we call this as a recursive functions. Let us see an example for a better understanding. Okay, this is the basic program for recursions. As I include the header files, then see there is the main functions. Inside the main functions, all the function calling operations can be done. There are two functions in this our program. First the main function, and we have create a function with the function name calculate factorial. This is the function name, and we pass int number as a parameter. Let us check how this program is run. Inside the main functions, we provide a initialize the data type as int, and we can give n as a number. Then check if enter print statement for user to check enter a non-integer to calculate this factorial. Actually, in this program we are going to calculate the factorial of any number, so that's why we initialize int n for getting an input from an user. Okay, by in the monitor the print statement using we display the words, and then the user enter the value of n. This is get by using the scanf functions. The value is integer, right? So we can give a format specifier as %d, and the value is stored in n, so we can give us ampersand n as. Okay, and then we have to check if the user give the negative numbers, means we have to tell user that is not possible to calculate factorial on negative numbers. So we have to check if the user gives a positive number or negative number. This can be done by writing the conditions. If n smaller than 0, that is smaller than 0 means that is a negative number, right? To check if n smaller than 0, then we have to print factorial is undefined for negative numbers. By this way, we can tell the user you should give only the positive numbers. Okay, if the user gives the positive numbers, what happen means here comes to this line, int result calculate factorial of n. Here what is done means calculate factorial. This is the function call. by calling these functions, compiler go back to the and search where is the function by in the name of calculate factorial. Then it's fine, and then it's performed the task. Like here n is an argument which is passed to this function. Okay. Then the n is passed to this function as number, and the compiler check if the number equal to 0 or the number equal to 1, it should return the value 1. That is, the factorial of 0 and the factorial of 1 is 1, right? So we have to return 1. This is the base cases. That is, if any one of the condition is true, then the function stops call itself. So we call this is a base cases. And let's see the recursive cases. Here, return the number into calculate factorial number minus 1. That is, the function call itself, again it's called, right, calculate factorial. This is a function call. This is why it's called as a recursive case. The function call itself many times, so we can tell this as a recursive functions. Okay, now if any number given as an input, first check for this condition. If this condition is false, then it's come to then else part. In else part, there is some calculations have to be performed, and then the output is written. How the output is written means the calculated value is stored in the result variable. Okay, inside the main function, the function call is done. After the function call, all the process has been take place. After that, the result is stored in the result variable. After that, we have to print the result. So in the printf functions, the factorial of percentage d, that is, this is a format specifier, and this is we have to print a number, means we have to given this format, right? So first is for the value n, and the second format specifier is for the value result. This is how this program is work. Let us check by running this program. Okay, here it asks for a number to calculate the factorial. I give 5. Then it shows the factorial of 5 is 120. How it's already told, like how it's work. First is asks for me the enter a non-negative integer factorial. Then I give 5. Then it can be done by the scanf function, and it also check the condition. If this is negative, then this is lesser than 0 and this condition is false, and then it's go for this line to calculate the factorial. Then the function is called, then it's again go to that function and check if the number is 0 or 1, then it have to return 1. Again the first condition became false, then it comes to an else part. Now what is the number here? The number is 5, and this and again this function calls and check with this, then find it's calculate the factorials. It checks. Okay. Then go to the int result statements. In this statements, the function is called. Calculate factorial is the function name, and it is called. Again the compiler go to this function and check if the number is equal to 0 or if the number is equal to 1. Our input is not like 0 or 1, right? So this condition is false and it goes to the else statements. Here the recursive factorial is recursive function is done, and we get an output, and our output is stored in that result, and the print statement of this is work, and this is what we see in the screen. Let us test by giving any negative number how it works. let us run this program again. Now I have to give a negative number to check if it works. Here it shows the factorial is undefined for negative numbers. Like as I told earlier, like if it checks it is less than 0 or input is less than 0, then this print statement have to be executed. This is how it works. Let us also check that if the number equal to 0 or 1, what will it return. Okay. I give 0 as an input, then the factorial of 0 is 1, because the first condition is true. So this is executed. Oh, wait a minute. Okay, here the condition is satisfied, so it's written 1. If I gave 1, now also the first condition is satisfied. Let's check that one also. Okay, now also the first if condition is satisfied, so it's written spawn. Okay, this is how the factorial program is done. The factorial program is an example for an recursive functions. Okay, thank you.
To obtain a course completion certificate, visit our site and finish the rest of the course video. Sign up or sign in, choose your level, watch the video and take the quiz. Finish all the quiz to unlock the final quiz and get your certificate. Happy learning!